Hey everyone, how's it going? It's been a while. You have to be frisked. You're supposed to say frisked. Okay. So, I haven't been working on Sonic on stream for probably it's been like a month, I guess. It's been a while. Um, I've been on vacation and that, and while I was on vacation, I was traveling on a ferry from Tassie to the mainland, which is about like a 10-hour ferry trip. So I went to I went on that ferry, and while I was on the ferry, I actually worked on Sonic a little bit off stream. So I'm going to show something that I've been working on, which is some bindings to something called Musashi. And so Musashi is a Motorola M68K emulator. So what I've been thinking is that we can use this emulator to emulate parts of Sonic rather than me having to re-implement everything from scratch right from the start. So I'll be able to reuse some of the functions. Did I change your game from programming to science and technology, or did Twitch combine categories? Twitch changed everything. I only found out this morning. Twitch changed everything. So now they've gotten rid of categories, and now they've gotten tags. And it seems like the tags are fixed. It's kind of disappointing because I created the functional programming category a while ago, and it looks like Twitch got rid of it. So yeah, that sucks. So the categories have changed. They used to only have creative. Now it looks like they got science and technology. So I've decided to use that. Seems like the most relevant. But then they've added all these tags. So I'm in the software development, game development, and I don't know. I added educational. I don't know if that's quite right or either. But yeah, I used to be in creative, and now I'm in. I was in the creative category, and I was in the programming community, and now they've changed communities over to tags. So. Doesn't seem like the tags that I want are there at the moment. I don't know if they're ever going to be able to, cause what they allowed before was that you could create your own community, and now it doesn't seem like you can create your own tags. So kind of stuck with what we've got, I think. I used to have Australian streamers on there as well, and that doesn't even seem to be a thing. So I don't know. It's good that they've cleaned things up, but I mean, it also limits us because we used to have a functional programming community, which is pretty good. Anyway, that's disappointing, but we'll move on. Okay, so I have, so let's look at this Musashi library actually. Musashi is a type of ramen, I guess. So Musashi M68K should show up something. Here we go. So this is a library written, it hasn't been touched in a while, I think. Oh, it's been touched in July. The most recent work, so this is version 3.4. So the most recent work is actually going into the main project. So I was looking around trying to figure out how most emulators work. Because what I basically wanted is just to emulate the CPU. I didn't want to emulate the graphics. I didn't want to emulate, anything input or anything like that, all the interrupts and stuff that the Mega Drive actually provides or the Genesis provides. I only want to emulate the CPU and be able to have my own hooks into the CPU. So I was looking into what libraries provided that. I was thinking about using the Blastum, which is the emulator we've been using. I've shown that quite a bit. So this is the emulator we've been using, Blastum. I had a look at doing this, and it had some stuff around emulating M68K, but it didn't. Basically all the logic inside of it also has stuff to do with graphics. So in here, there's something to do with graphics. I could start hacking this library up and commenting out the parts that we're calling back into update graphics and that, but I decided against that. I didn't really want to do that. So then I found this library, and this is really just an emulator. It provides hooks into handling the interrupts and that. So basically, it's got nothing to do with graphics or anything in that. You just handle that with your own kind of handlers. So the configuration lets you specify. I mean, they've got compile for main, which has got some special stuff in it as well. So you have to disable that. But yeah, you can say here's the callback for interrupts, reset callback. So if you press the reset button, instruction callback. So you can actually have instructions for every instruction. A callback for every instruction, which is interesting. So this is the way that they use the library in main. The library is actually developed a little bit further in main, but I found this version on GitHub, and I just decided to start using this instead. This is kind of like the original author. It has been developed a little bit further in the main project, but so if you look at the main source code, you can actually find this source code basically copy and pasted into the project. So yes, so I can actually use this library to hook into, you have to just implement these things. And then you can say basically execute, give it a ROM, and then it will go off and call these things. So this is where you specify your own memory implementation, and then it will go through and actually execute it, which is super, super cool. So the goal behind this is that, yes, my Sonic 2 clone runs without an emulator. I've been stuck on quite a few functions, so you know that we've been screwing around with, in main we can see quite a few things I've been screwing around with, like this angle pause function. I've been screwing around with this for ages. Calculating the angle out, doing the level collision, hitting the right. So I've re-implemented all of these, but there's some things in here that aren't quite right. And what I want to be able to do is write tests and say this function should behave exactly the same as the Sonic 2 function. So there's a couple of goals. One of them is I can just say instead of sine. Yeah, here we go. So I've got this calc sine. Yeah, I've got this calc sine function in here. Yeah, calc sine. So I've implemented this, and I think this works. But it'll be good for me to be able to just, comment this out and say, actually, just use the one from the Sonic ROM. Or it'll be good for me to have this implementation and test it against the Sonic 2 ROM. So there's kind of two goals. One is that I can reuse code from the Sonic 2 ROM and just execute it. So if I ever get stuck on a function, I can just say, screw it, I'll use the one from the Sonic 2 ROM. And it'll allow me to test. So that's kind of the goal. And I have something working, so let me show that. So Musashi, if we look at the main, I have this working. Oops, ignore that. So this will load up the Sonic 2 ROM. It'll allocate memory. So this is about like 16 megabytes of memory. This is like the address space that's available to the Mega Drive. So once we got this memory, what we can do is say, set that, like the Musashi is like an emulator, so set the ROM to be that memory, like this whole memory that we just allocated. And then we copy our ROM into that memory. We say init, which is just sets up some stuff. And now we've got access to this calc sine function here. So you can see calc sine is a function that takes our unsigned int to an IO unsigned int, and what it does is it sets the subroutine in Musashi. So I've got like an internal it sets like the what would you call it, the program offset to my offset here, sets up some registers, and then says run. I think I can actually improve this run function. Actually, I was thinking about this last night. I can actually improve that. Yeah, all it really does is just read stuff from memory. There's a little bit of stuff I had to do around memory. It's about the endianness of the Mega Drive. You have to be careful around the endianness. But yeah, all it does is it sets up the CPU, sets some memory, and then executes it, and just executes the ROM. It's pretty straightforward. And so what we do is we set up the registers, call run, and then we get back out the values from the registers. So it just really just executes it. And this, I was a bit worried that the Musashi might not be able to execute all of Sonic, but then I was thinking, well, it's used in the main project, and main can definitely execute Sonic. So this should be complete enough. I actually was looking at a Unicorn, this Unicorn project. So this is really cool. Unicorn is super cool. It gives you bindings to be able to just execute parts of well, anything really. So it's just like an API for QEMU. So QEMU is obviously an emulator. It just gives you a nice API to use it. Actually has a Haskell API, and I had a look at that, and it actually works really well. The only problem is that its QEMU's M68K support is not complete. So it's not anywhere near as complete as this Musashi thing. So I'd really prefer to use this Unicorn, but it's just QEMU doesn't support M68K enough to be able to execute pretty much any Sonic function. So that was super disappointing. But anyway, Musashi looks good. I've been playing around with it. This actually, so I'll show you. I'll be able to run this. It's a little bit tricky, but I'll run it. So now let me, so this should give me access to the Musashi library that I created. So this is Haskell bindings to the Musashi library. So I created this, so it lets me do things like, yeah, set the ROM, in call run and things like that. So now I've got this, and I should be able to say, oh, that's not working. Okay. Oh, right. Sorry, I just need to bring these in. Hopefully that should work. Guys, yes, we got Musashi available. Cool. So now I should be able to run Haskell main. Right. So here we can see, so that if we go to my main, what I did is I said calc sine offset. So if I look at the Sonic2 disassembly again, so there's a calc sine function. And look at the address it's at 33B6, and you can see here all I've done is specify 33B6. You can read the documentation here. It says D0 is the input, so D0 is an input, so you get out an angle, so 360 degrees equals 256. So there you go. So that's what I'm setting there. I'm setting register D0, so I'm saying the input, so I get to specify the input byte, and then I call Musashi run, which actually executes it, and the output, well, the registers now, so I've got an output for the sine, and then I have an output for the cosine, which I actually haven't read out, so I'm only reading out the sine. So this just reads out the sine, which is pretty cool. So this actually executes it out, and I've got this main function down here, so it goes through 0 to 128 and prints out the sine wave. So this should represent a little sine wave. And I mean, I'm not very good at reading sine waves in output like this, but I think that looks like it might be a sine wave to me. So yeah, I'm really happy that I'm actually executing the Sonic ROM through Haskell. I'm like, well, I mean, the Haskell is just calling to a library that's actually emulating it, but I actually got like a nice API for calling into the Sonic ROM, which is super cool. Time to make a terminal function plotter. I'd love to spend some time on that. Yeah. I realized that my terminal actually is able to display images. I use this Kitty, I think it's called Kitty. Yeah. I use Kitty, and that can display images, so it'd be cool for me to actually spend some time on that, but I haven't gotten around to that. Okay. So that is calling Sonic2 ROM's subroutines. What I want to do now is try and, I guess I'm going to have to work a little bit more on this because there's more registers I need to specify and things like that, but what I want to work on now is trying to use that to test some functions I have. So I can actually write some tests, I think. So I want to write, some tests. Actually, what I'll do is I'll just make a test suite for now. I can never remember how to do a Cabal test suite. So this is kind of be like integration tests. Testing with a function written by someone else has already proven to work. Yeah, exactly. Yeah, that will make things a lot more simple for me, so I can actually run my calc sine function and see that it works. All right, should be pretty straightforward. So hopefully this will fail. Yeah, cool. It's failing because I don't have the Musashi thing in my shell.x. I'm at default.x. Cool, so I should be able to say Musashi is and this should fail because it doesn't have lib Musashi involved. Yep, that's good. There we go. This might work. So now I should hopefully be able to do cabal test. Oh, no, it doesn't like that. Oh, right, because, yeah, it doesn't like that because I have to do something for this. Yeah, I have to add a flag for it. Yeah. Hopefully that'll work. You had issues devising tests because it was basically repeating logic. Yeah, tautological tests are quite a problem. That's often a problem people face when doing property-based testing as well, especially with property-based testing. Usually the property is that, usually the first property that people think of is the property that the function does what the function does. It takes a bit of skill to, or a bit of practice really, to be able to figure out exactly what's a good property, what's a good algebraic property of a function. What's happening here? Hey Soding, how's it going? Oh, that's right. I've done it in the wrong place. There we go. You've been doing some really good videos. I really enjoyed that one about applicative and monoid. Really, really good. If anyone hasn't seen Soding's video, look up, what is it? Applicative monoid, something like that. Not that one. Yeah, this is what you want. Relationship between applicative and monoid and reusable code. Have a look at this video. It's super, super good. Highly recommend that. Oh, that's right. Sonic 2 is an executable. I need to start making this into a library. Best way to understand things is to discover them yourself. Yeah, it really is. Yeah, I've rediscovered a lot of existing things. If I come up with an idea that hasn't been discovered already, then I'm usually in the wrong direction. So hopefully I can write what I really want to do is my first test, which is to do the calc sine like I've got working. Just test that calc sine does what I think it does. like that, yep. And that makes sense why it doesn't like that, cool. That's fine. Alright. What I might do is make a new module in... Yeah, I'm gonna make a new module. Yeah, that'll do. I'll make a new module under here. There's a way to get Cabal to... Emacs has got like a Cabal reformat thing. I can't remember what it is. Someone told me on Twitch a while ago. Someone came on chat and told me, hey, there's a key for that, and I can't ever remember it though. Was it Cabal? Maybe sort? No. Nope. There is a key for it. But anyway, we'll do it like that. Game. So we'll go to, what I'm going to do is make a Musashi dot, yeah, I'm going to make a Musashi.hs. And my Musashi main, so this example that I had, I'm going to basically make it this. Something like that. Undefined reference. That's interesting. Why is it undefined? Because my Musashi.hs has it defined. Yeah, it's trying to link this in, but if it links in the right library, okay, do I have to actually import it? Yeah, okay. No, it still doesn't like it. Okay, that's what I like. Okay, so you actually have to use the library for it to be linked in properly, otherwise it's going to give you errors. Okay, that's a little bit annoying. I've screwed up a little bit. Like, I've got this as a shared library that doesn't have all of these symbols defined. So that's really the problem. And so I'm relying on Haskell to kind of export these symbols. Really, I shouldn't be doing it that way. Yeah, there's a better way for me to do that. But anyway, we'll go with that for now. I've got it kind of working. It's all a bit dodgy. I need to really clean that up a little bit. It's just that, yeah, I'm relying on these symbols to be exported from Haskell. So GHC should be generating these symbols, and it does, but only when you actually use the library, it looks like. So GHC doesn't always do it, because, you know, GHC is obviously a little bit lazy. Yeah. Actually, it says it's failed. Why did it fail? Why did that fail? Oh, okay, because my Musashi init's probably failing, actually, because I don't have any ROM loaded. Yeah, okay, that's fine. Because it needs to do something basic like this. Okay, we're getting somewhere. Passed. Cool. So it's loading it up. It's loading up and it looks good. Cool. Okay, and now what I might be able to do is import, what was it, game. Yeah, I need to change this around. So I need to make like a source directory, and then I need to make a source directory. And how do you do the directory thing? Whoops, directory. Yeah, HS source directories. Alright, try this. He's screwing around with all this stuff. I just like to write functions. Oh, there is something that I wrote which wasn't a function. I actually did some not functional programming. I was a bit unethical. I did this. Look at that gross thing. That is gross. But you can do it via C instead. If you're able to call C code, then you're able to do something basically like this anyway. So yeah, but it's not good Haskell. But yes, it does. I don't know. Cool. Okay. Let's see. Okay, so that was that. Okay, so tests are passing. So it's actually loading up the ROM. Now let's make the tests print out the calc sign. This is not what I want the test to do. Obviously, I want to actually write assertions rather than printing out the result. I need to use a different prelude as well. This sucks. Why aren't those imported by default? Cool. Now, if I print the log, does that actually have anything useful in it? Yeah, it does. Cool. There you go. There's sign. Cool. So I'm actually getting results from my calc sign. Now, what I want to do is also, I have, what is it? Angle? No. Oh, I do have sign.hs. That's what I want to use. So I want to test that my calc sign behaves the same as this calc sign. Just assert that they're the same. And hopefully they are. Yeah, okay, so my Musashi.hs. So this is what I could use, I'll delete that off. Will I ever do any more .61 FP course exercises? Yes, I definitely want to. I recently did, so for work, I've got a couple of classes going on. I'm actually going to spin up another class very soon, actually. Got a new team in India that I'm going to be teaching, and yeah, I've been going through this with one of my classes in Atlassian, and we went through and we did. They're currently on tic-tac-toe, and I think that's where we're going to finish off. But we went through recently and we did state and state T, and those are pretty good. Is there anything else we did? I don't know. Did I ever get to the more parser and JSON parser? Did I do the JSON parser? It looks like I did not. There you go. That's something that we need to do then. Cool. Okay. So yes, I will do some of this. I will do some more FP course. What I want to do is state T. Those are good. I haven't done extending comonad yet. I haven't taught that in any of my classes. I don't know. Like, I definitely don't want to do list zipper. I think that's a bit boring. But extending comonad, I might want to do them. We haven't done anagrams or the check or anything like that. We skipped all those. So maybe more parser and JSON parser. Like, those are really, really good examples. Really good exercises. So Yeah, so we should go through these ones. So state, state T, and parser, more parser, JSON parser. Those are really, really good. So I do recommend them. Really love to see those two, state and state T. Got quite lost writing the instances. Yeah, okay. Yeah. They're really good exercise. They actually motivate, like, you can see state and then you can see state T. You can see the duplication between it, and you can also see, because we've already done compose and traversable, and so those kind of motivate some of the reasons for state T as well. So I kind of like going, like, I don't like doing it in this order. I like going list, funct, replicative, monad, file IO, and then motivating state and well, I mean, state you can motivate, but state T, I like motivating it by using compose and traversable. Those really motivate why state T should exist. So then I like going back to state and then state T. And that's worked out really well for my classes. But yeah, parser and more parser and JSON parser, everyone loves those. Every class I've done, when we get up to JSON parser, everyone loves it. It's really, really good. I highly recommend, if you want to learn functional programming, have a go at this course and get up to JSON parser. It's super good. Really highly recommended. Everyone that does my course seems to love that one, so it's really, really good. It's also very practical as well. Tackling state and state T, join the Queensland Functional Programming channel on Freenode. Oh, just realized that I'm doing it now, sorry. No, I'm not actually doing it now. I will be doing it eventually though, because I've done pretty much everything except for state and state T and yeah, the JSON parser. Well, the parsers and JSON parser. So I will be doing that at some point. I really want to. I've got a lot of requests for doing that as well, to get back onto FP course. So yeah, I'll do that. You've done a really good job with the JSON parser. It's really good. Everyone that does it likes it. I don't think anyone in my class disliked it, so it's really good. Maybe I can do that next stream. Maybe next stream we can do state and state T. Stream after that, then we can go on to parsers. What is the config of your PC? So I use something called NixOS. So NixOS is it's a functional Linux distro, really, really good. What it does is declarative configuration, and you can actually see what I use on GitHub. So here's this is on the, I've got a couple of different computers, but this is the one I'm using at the moment. And so this is the configuration that I have. So I don't know, you can see some things in there. I'm obviously using pulse audio, and I don't know, wireless is enabled. You know, really, really straightforward things. So this doesn't show you all the software I use. If you look in, so I haven't actually uploaded my user config for what I'm using at the moment, but what you can see is, if you go to Carbon X1, you can see a lot of the software I use under this user.nix. This is a lot of different software I use. Yeah, at the moment what you're seeing though is like a little window on my screen. I'll kind of stream from like a little window, and I'm using i3, so I use i3 as the thing. Other than that, it's just Emacs and Kitty and things like that. Where do I place my ZSHRC settings? I don't really have many customizations. I use I just did the, what is it, own my ZSH or whatever it is. I just copy and pasted that, so it's really straightforward configuration. I've not really done anything to it really. Functional programming is not needed. It's not fast and not scalable like object-oriented programming. All right. You've been thinking to switch to Arch from NixOS, or are you talking about the other way around? To NixOS from Arch, yeah, okay. I highly recommend NixOS. I think it's absolutely awesome. I use it for everything. As you can see in my Nix files, I use it for absolutely everything. I use it for work. So I use NixOS for this computer I actually stream from my work computer, which just because it's got a bit more power. So I use that for my personal laptop. I use I have this configuration, so I use NixOS this is for a media center I've got going. This is using, it's actually a Chromebook. I had an old Chromebook laying around and I was like, well, I may as well use it, so I put NixOS on it. Really good. I've got an old EPC that I've had for like 10 years, and that's hanging around. That's got NixOS on it. I've got a MacBook around here which is running NixOS. I've got a little orange Pis. These are the, I don't know if I've got one here. Yeah, here we go. This is called an Orange Pi, which is a single board. What do you call it? SBC or whatever, single board computer or whatever. Yeah, that works. That runs NixOS. What else have I got? Well, obviously I run it in Docker and things like that, and everything at work. Actually, on my router, I actually build packages that I run on my little ASUS router. It's just a statically linked. I've got a couple like statically linked libraries. Like I've got rsync or something on here, so I've built packages for my router, statically linked, and push it over, which is really, really cool. So yeah, I use Nix for absolutely everything, and I make for work we make our Docker images using NixOS. Well, sorry, I'm using just Nix. We use so Nix Docker tools. We use Docker tools for deploying everything for work. So I highly recommend NixOS. Really recommend it, and I use it for absolutely everything. We actually used Graham C. Where is he? He's done some work on Nix and Docker, and we've just really benefited from this. Yeah, exactly this thing here. Really benefited from this. So he's made like an algorithm from automatically creating layers from a set of things you want to install. So obviously Nix uses a tree for everything, and he can kind of, what Graham's done here is decomposed everything into layers. So you can actually build Docker layers from this big tree. Super good, so good. Functional programming working really well. Okay, so I'm catching back up on the chat. Not straightforward for some reason. NixOS settings with Xmonad and ZSH enable ends up with white theme. Interesting. I don't think I've had that problem. Yeah, I don't think I've ever actually seen that. Yes, I am making a Sonic game. Well, not really making a Sonic game. I'm remaking a Sonic game. So I'm re-implementing Sonic the Hedgehog 2 in Haskell. Yes. So I'm just taking like the disassembly for Sonic 2, and you can see that there's a lot of it, and I'm trying to port as much as I can over to Haskell. I understand what problems functional programming can solve that object-oriented programming couldn't. Well, first you'd have to define what object-oriented programming really is. I don't think anyone's got like a strong definition for object-oriented programming. The reason why functional programming though, I mean, not in contrast to anything other than non-functional programming. So, you know, functional programming is just programming with equations, just programming with values. That is functional programming, and so non-functional programming would be programming without values. So this is things like side effects. So what problems can functional programming solve that side effects couldn't? Well, there's nothing there, right? There's nothing that you could use side effects to do everything, right? So there's nothing really that functional programming solves that side effects couldn't, but there are problems that functional programming take on, which is reasoning about your programs and also code reuse. So you get a couple of big benefits from doing functional programming, and you don't really get any benefits from doing side effects. There's nothing that side effects give you that functional programming can't give. That's really it. Just functional programming is only benefits. Here's something that I have not seen anywhere else. Not even close. lens. So I mean, if anything can get even close to lens, then I'll be considering it. But until we get lens, until the alternatives of like if there was such a thing as not function programming, if that was able to give a benefit that produced something better than lens, then I'd be on board. But I don't believe that to be possible. Lens exists because of functional programming, and it can only exist because of functional programming. And lens gives a massive amount of code reuse, and it benefits me every single day. Yes, you do have a Twitch, it turns out. I want you to use it one day. Well, other than chatting. To actually stream, it'll be good. So QFPL, if people don't know, is the Queensland Functional Programming Lab. And so they're in chat, which is good. And I want them to stream. Here we go. Okay, so this is, what was it, sine and cosine here. So we've got those values coming out. Interesting that interesting that we get these values coming out. Wonder what, oh, because, right, interesting. Okay, so I've been using unsigned integers, because that's what the registers really are implemented using. The Musashi API gives you back unsigned integers. Looks like this will be a signed integer here. So we need to actually read it back into a signed integer. Do you see the link going around recently that Mojang's lens is in Java? Yes, I did see that. That's super cool. Let's bring that up. What was it? The data... What was it? Data fixer upper, was it? Something silly like that. Yeah, data fixer upper. Yeah. Not only are they lenses, but they're optics and they're profunctor optics. Yeah. That's interesting. I actually haven't looked too much into it, but I should, because I'll be interested to see like how they do. Obviously they don't have high kind of type. Oh, they're doing that dodgy. Looks like they're doing the dodgy. What do you call it? The faking of high kind of types. Yeah, here we go. It does the kind. Dodgy kind thing. What's the name of this? Like, I mean, look how dodgy that is. That's super silly. What's the name of the yeah, if you look at functional Java, yeah, we've had this in a while, functional Java. Whoops. So I have used functional Java in production before. It's actually pretty good. Here we go. So this is how I would expect us to be able to do optics in Java. So you go to traversal, but look at all the modify functions. So you got modify IOF, modify trampoline, modify promise, modify list. And all of this will just be code duplication because we can't express higher kind of types in Java. So what you end up with is just code duplication. So you just copy and paste, copy, paste, copy, paste. What they've done over here is instead they've got this dodgy thing, and instead they just cast. So instead of copy, paste, copy, paste, copy, paste, they write their code and then cast. So they write their code once and then cast. I am personally on the side of copy, paste. I do not want casts in my code. I would prefer copy paste. Rather than work against the type system, work with it and just live with it. Sadly, Java requires you to copy paste. Make it clear to everyone that when you're working on it that you're going to have to copy and paste because that's what Java requires of you. But I would prefer that than to do this. We've got a comment here saying A to FA. It's just this is going to eventually be used just to do a cast. So I am on the side that you just write the code, you just copy and paste and copy and paste. And you live with the fact that you're going a bit slower because you have to keep stopping and copying and pasting a new function. but you live with it. You also lose a little bit of reasoning because higher kind of types give you a type of reasoning that you don't get otherwise. But anyway, that I think is better than casting. Yeah, I agree. Copy paste is better than turning the type system off. This is what is it? This goes back to this this package, which is based off a paper. I'm trying to think of the paper name. Lightweight higher kind of polymorphism. That's the paper. This came out and basically advocated for doing casts rather than doing code duplication, and they justified the cast in some sort of way. There's some sort of justification for the cast, but it's still working against the type. You still turn off the type system at one point. There is a little bit of a justification, so it's not as awful as what I'm probably making it sound. Like, you're not completely turning off the type system, but you are turning off the type system for a particular place that they justify. But I just prefer just to copy paste and just live with it. But you've probably seen that. You might have seen. I mean, if you're doing Swift or what's the other language? What's that one that's based on OCaml? Reason ML or whatever it is. Or you're doing, I think, TypeScript. There's all these different languages that have based that have a library that's based off this paper. I prefer it. Yeah, I definitely prefer a tool that does copy paste for you. Even better when it's not actually copy paste. There we go. This is looking better. Look how good that is. Cool. And I think that should be up to 256. Is that inclusive? At least we have the clipboard. Yeah, I mean, yeah, what we need to do is just write a heap of macros. I mean, especially if you're writing Go, then you don't even have any polymorphism at all. So you just got to copy paste, copy paste, copy paste everything. Java's got less copy paste than Go. And Java's got a lot of copy paste, so that's saying something, isn't it? Cool. I'm happy with that. So this is calcsine. It's calling into the emulator and emulating it. What I've done before is I think I made a mistake over here. What I was doing is in my execute function over here, I specified the clock speed of 1, and I just kept executing until we had no cycles remaining. And I think I needed to do that because eventually we'd get past, like it kept executing past the subroutine I wanted to execute. But I've actually made it so that it halts after the execution of the subroutine. So I think now I can actually bump that that cycle count up. I don't know if that'll do anything, but there you go. Certain good idea to take away type slash when it writes memory. Try to use larger values for your calls since it will increase throughput. Well, it's fast enough for now, so I'm gonna leave that. It's fast enough for now. Like, you can see it was actually pretty fast to run all the tests. You can see the log. You know, it's calling the function a lot of times, and well, I guess only 256 times. But anyway, it's fast enough. You know, it doesn't take seconds to run. So I'll leave it at that. So, okay, so we've got calcsine. So what I want to do is write my calcsine property, which I guess means I need to import Hedgehog. That's going to be funny. So I don't, if people don't know Haskell very well, there's a like the best kind of library for testing code is Hedgehog. Hedgehog will eat all your bugs, and what we'll be doing is using Hedgehog to test Sonic. I'm pretty happy with that. Using Hedgehog to test Sonic. I think it's just so awesome that we've got this code which goes off and actually executes part of the ROM. It just calls one function in that ROM. You know, there's a function that calculates sine waves. Super cool. Super cool. Okay, so we've got Hedgehog, so I'm going to make a property. I can't even remember how to do this. It's like, is it for all? Oh, that's right, they've got a monadic version, yeah. That's right, and they also have... This is a good thing about Hedgehog. So versus so in contrast to QuickCheck uses type classes for all your properties. So if you want to say I want to generate an N, you say give me an int64, and you say it's type directed resolution. So you say give me an int64. It goes and finds a way of generating int64s. Now this one you can obviously have more control, so see how this one's like linear bounded. So we've got a lot more control when we write our properties, when we don't have to use type classes. And so that's really the difference between Hedgehog and QuickCheck. Well, one of the big ones. One of the big changes is that we have just first class values that we pass around rather than using the type directed resolution. Okay. You're reading the Hedgehog docs. Is it like QuickCheck but with better interface? Exactly it. That's exactly what it is. QuickCheck is quite a bit dated. Like everyone had the same criticisms about QuickCheck, and Hedgehog pretty much solves pretty much all the problems with QuickCheck. I mean, there's still some things that you could improve on, I think. Some different strategies we could do, but Hedgehog does a lot better than what QuickCheck does, for sure. Yeah, here we go. When I was up in, so I went, like what I was saying before, is I went on vacation. I actually travelled up to Brisbane, and I actually stopped by the Queensland Functional Programming Lab, and I was talking to the people there, and they wanted to use Hedgehog, but with Eita, right? So if people that don't know, I've been working on Eita Lang. I've been working on getting Eita to work really well with Nix, and working on the integrations there. I can actually bring up the documentation real quick, because I just updated the documentation recently. So if we go to the documentation, there should be something here about, where is it? Maybe in here. Nope. There we go, Nix. So this is some documentation, alright. So I've been working on this thing to make it really easy. So it used to be that you used to run Eita shell and used to run this install and that, and I've changed that around now. So we've actually got something called Eita packages, and you can just run any, you can call any Haskell library using Eita packages. So while I was in Queensland Functional Programming Lab, I was talking to people there, and they want to use, they want to play around with Eita a little bit, and so I've been, so I was playing around with I was testing out my Hedgehog and Eita integration, sorry, my Eita and Nix integration, testing out Hedgehog, and we came up with a problem. We came across a problem. Here we go. So the problem that we found while I was trying out Eita and Nix with using the Hedgehog library was that it was depending on Unix. And Eita doesn't support the Unix library because it's running on the JVM. We don't really have all the ways to bind into the low-level details that Unix needs for it to implement it, really. So if we go to package, we look at the Unix package, you can see there's a lot of stuff in there, and JVM doesn't have support for every one of it. So there's a lot of stuff in here. So dynamic linker we don't have support for, as far as I can tell. There's a lot like signals and things like that. Like we'll have a limited amount of support for all of this stuff on the JVM, so we don't support it. Maybe one day we'll figure out how to support it partially or something, but at the moment we don't support it. So Hedgehog depends on Unix. Why does it depend on Unix? It depends on Unix to read out the username and check if it's MTH, which is Mark Hibbard, which is the guy, which was basically their boss. Detect Mark, so Mark Hibbard, they were basically detecting their boss. If they detected their boss, they would then disable colors because their boss didn't like colors on the terminal. So they'd get out the username, check if it was MTH, and then disable colors on the terminal. And because of that, they had a dependency on Unix, which meant it wouldn't work on Eita very well. So we actually had to patch the library to get it to work on Unix. Instead, what we came up with, pointed out by a couple of people at the Queensland Functional Programming Lab, is that we could just look up the user environment and just check that. Super straightforward. So now we've gotten rid of the Unix dependency. So now this works on Eita. That's the point of the story. I went to Queensland Functional Programming Lab, found a dependency on Unix, got rid of it, and the only reason that we had a dependency on Unix was because we wanted to disable it so that they wouldn't get fired because their boss hated colors. Why have config files when you can hardcode config options for every user into the source code? Exactly. I need to go in there and add if user is Brian, then I don't know. We'll have to figure out something. Perfect example of how management ruins the industry. I hate colors. Now you got a dependency on Unix. It's a good joke though. It is a good joke, I have to give them that. Oh, that's right, that's why I was in the Hedgehog repository. Sorry, I got distracted when I was in the Hedgehog repository. I was trying to find, here we go, example. I want to see, there's a way to run it. There's a proper way to kind of run it. I'm trying to find that. I feel like this should be like provided by the library in some way. Mark if it has a medical condition where colors cause problems. Oh, okay. Almost got Hedgehog working. Oh. Change the result. I think I was meant to set the line buffering unless that's been changed. There we go. So at the moment this is just asserting that n is n. We need to do a little bit better than that. We need to assert that our calc sign that we have. And I have to lift IO, don't I? Oh, whoops. This is one I wanted. I imported the wrong one, qualified. I thought that was a bit weird. Okay. That's the one I want, qualified. Yep, need to import lift IO. Okay, so that is, so I need to generate a, what is it, a CU int. But I actually think what I probably can change is this. Cool. So that is testing the calc sign from the ROM. That's, oh sorry, it's not testing it yet. It's just running it. So it's running the calc sign from the ROM. The next one will be to run the calc sign from what I've implemented. So I've implemented one in sine.hs. So this one. So this is the one I want. Calc angle. No, that's not the one I want. Actually, yeah, this calc sign. For some reason that takes a word 8. Yeah, maybe that's what it should be, word 8. Okay. I need to give it the sine wave data, which I can get from it's pretty gross, but that would work. So sine data, so we'll make a function called load sine data. I've got a cycle. Okay, that's right. This is kind of meant to be the bottom level. Okay, that's fine. Yeah, we'll do it here then. We're getting somewhere. What's has run look like? Okay. What's wrong with that? Oh. There we go. All right. Okay. So given a has ROM, right? So we have to say has ROM, which is just byte string. Okay, cool. All right. Well, we've got that accessible. So I'm just implementing some of the type classes I have. So I have one for like Hasrom, which is a lensy, what do you call it, a classy optic, classy lens. And we're getting closer. Is it eval reader, run reader, run reader? Really what I should be doing is, how do I do it? I want like a reader T of this. I had that flipped, that's an easy fix. Did I? Oh, it's a getter and setter, isn't it? Whoops. Yeah. There we go. Okay. Just bring an MTL right. Hang on, no, I did have that right actually. It's just not liking it. I'm gonna do something dodgy for now, because I don't know how to put a transformer into Hedgehog for now, but I'll figure it out. Okay. Right, so now I have to run that again, right? What I need to do, actually what I need to do is, that's what I need to do. And up here I need to load it. Okay. What I probably could have done is, instead of defining this, my multiply string. That'll make it easier. What can I even do with that? That's like an eq even. Can I just do ID? That's right, ID is a valid one, isn't it? I think it's a valid optic. Yep, looks like it was. Cool. We're getting closer. Okay, that was part of the problem. And this as well. Keep forgetting these have got nothing to do with I/O, so. Look at that, BS needs to be sine data. There we go. Now it's going to actually execute. Will it pass? Will it fail? Did that actually pass? Did that seriously pass? I did not expect it to pass straight away. I was expecting that to say fail. If that's actually working, that's pretty slick. I'm pretty happy with myself with that. Check that out. Check that out, that's awesome. So my implementation of calcsine was correct. That's what that's showing, that's awesome. You can see here we're actually, so this one's, you know, the calcsine that I implemented. And all it is just reading out values. Like, I shouldn't be too impressed because really all it's doing is in the ROM we have this data. So what emulating this ROM does is it just reads out the values that this generated. Yeah, so you can see here sinewave.bin. So really it's just reading the values from sinewave.bin. That's all the Sonic ROM. When we emulate it, that's all it's doing is it's just the sine wave is, you know, obviously at a memory location in the ROM, and all of these instructions are just saying, hey, read out those particular memory locations. But my implementation reads the same file and reads the same memory locations. So I'm happy. I'm happy because both the ROM actually, when you emulate it, it reads the same memory locations as what I've implemented. So my calcsine is correct. So that's awesome. Cool. I'm going to commit that because I'm really happy with it. How long have we been streaming? An hour and a half. Okay, we'll go for a little bit longer. Anymore. Cool. I'm going to say it's an integration test because, you know, it's actually executing the ROM. So there we go. How slick is that? It executes the ROM and it tests it against the implementation that I wrote. Cool. Now, the real motivation was, I mean, it's good for me to be able to write tests, so that's part one. So really I was having a lot of problems with implementing some functions in here. So like, I don't know if fine top might be right, but there's things like find wall. I was having a lot of problems with that, find floor, and it's kind of tricky for me to figure out exactly what the problem is at each point. Do level collision, I think I've got some of that right, maybe not. You know, there's obviously sonic angle, that's fine. I mean, it'll be good for me to just say, hey, sonic angle, just import that rather than me implement it right now, just because I want to be able to, you know, play around with the angle stuff. But there's a few things in here that I was having a lot of different problems with it. So it would be good for me to actually be able to use things like find wall and find floor. Now that's going to be interesting because it's going to read from, like, it's going to have to actually read what Sonic's values are. So it's actually going to have to dereference a pointer that points to where Sonic's data is and that. So I'm actually going to have to like serialize all of that data from Haskell data structures into the ROM, store it at particular locations, and then execute the subroutine. But I can do that, and that means that I can actually test these functions. So test my find floor and test it against like an actual implementation of find floor and check the differences. So that is really the underlying goal. Like calc sine, I didn't really actually care about because I was pretty sure that was correct. Turns out I was right. And now these are the ones that I'm really worried about, like find wall 2. These ones I've been struggling with a lot for the past couple of months actually. So I've been struggling with doing collision for a couple of months now, and that's getting a bit boring. So I want to be able to test these as I go, which would be really good. Is Learn Your Haskell any good? Not really. It used to be pretty good. It used to be kind of like the best resource out there. What I would recommend instead is this book, the Haskell book. I've got a copy of it and it's really, really good. I highly recommend it. Even if you're a little bit experienced with Haskell, I mean, if you're looking at Learn Your Haskell though, you're probably not very skilled at Haskell. And so it starts off really basic, really good. It's like really basic. But even if you've got some skill with Haskell, and you're kind of still learning some concepts in Haskell, like there's really good chapters around here. I really like these chapters. This is kind of where I've read like a couple of these chapters around here, a couple around here. Really, really highly recommend these chapters. I haven't read too much about these, like the basics, but I've heard really good things. And if it's anything like these chapters that I have read, then that must be really great, because the rest of it is. So I highly recommend this book. It's not the cheapest book. I think it's like, I don't know how much it is. $59 US. So depending on exchange rate, it can get quite expensive. If you contact the authors, if you're a student or something, you can't really afford it, then contact the authors. They might be able to help you out a little bit. But I highly recommend this book. It's really, really good. Only know C, so basic is good. Yeah, it'll start off probably assuming that you don't know anything about programming. I think is the beginning of the book. It assumes you know pretty much nothing about programming, or you might. It might require some sort of computer skills or something. But if you know C, you should be set. It might be a little bit boring at the beginning, but I'm not sure. Cool. Let's spend. I'm probably only going to stream for another half hour or so. So let's spend some time trying to write some tests for these functions I have. No, it is going to be tricky because it's got level data that has to be loaded. What else? Yeah, we'll see what we can do. What we'll do is we'll try and execute the function to begin with. So let's have a go. What do we want to see? What's like kind of like the most, I guess the most low level one. So I guess find tile, but I think we got find tile right. Yeah, we got find tile right. So let's go find either like find floor 2 maybe or something like that. Actually, let's go check. Yeah, let's go check. Oh no, because check uses the find function. That's right. Yes, so let's not do that. Check where full distance. Yeah, so check calls find. So I'm guessing we're gonna have to go find. Make sure our find is all right. Okay. So we'll do find wall 2 or find. Let's go find floor 2. That seems like it might be the most straightforward. Find floor 2. Let's try and execute that. And that's the location. So we're going to set the subroutine to find floor 2 offset. And it returns 3 things. It returns block ID, distance, and angle, which I made into a data structure called wooldist, didn't I? So I've got this wooldist. So I'll have to move that to somewhere. I need to get back a wooldist. And what does it take? It takes a vector. I'm gonna have to give it basically the same signature as what I got down here. So it takes, it takes a vector of sine. Oops. Whoops, wrong place. Here. Cool. Alright. And what does find floor 2 accept? D1, D3, D5, D6, and D4. Oh, sorry, A4. Okay, D2, D3, D5, and D6. D5, D6. It needs an A. What was it? A4. So A4 is something. A4 is a pointer to an angle buffer. Pointer to an angle buffer. Okay. Yeah, we can do that. Yeah, we can do that. That's fine. Okay. It's a lot of registers, and then we get A1. We need to read out A1. We need to read out D1 and A4. We actually need to dereference A4. That's what the parentheses mean. Oh, we actually also need to dereference A1 anyway. Well, we'll get to that. Okay, yeah. So I need to implement some more of my registers. I never implemented a lot of them, so that's fine. I need to implement them. And I need to bring in the constructor for wooldist. Okay, cool. Yeah, I need to do, looks like I might just need to do some, well, I need to do a from integral on that one. And then on this one, I need to dereference it, don't I? I need to actually dereference it and read out the memory at that location. But that is fine. Actually, I can easily do that. You can do M68K memory, what is it? Read memory 16 of A1. Can I just do that? Yeah, cool, awesome. And then this one will be something similar. rememory 8 of A4. Now give me a word 8. Cool. We're getting there. So it doesn't like my A4 for some reason. That's weird. All right. Hang on. How come it likes one of them but it doesn't like the other one? Oh, okay, it doesn't like one of them. Okay. So read memory. I think this is wrong. Yeah, so if I go to my Musashi checkout, I don't even know what I'm checking out. So if I go over here and I look at the header file for reading memory, reading memory, no, that's not there. There we go. Yeah. So that actually is an unsigned int. Yeah, that is a C unsigned integer. Yeah, I'll have to reload this. But I should probably implement some more of these. So D1, D2. Thanks for the follow. Deadly Toe. D4, D5, D6, and D7. And now I need to go into the A's. And we'll skip the rest for now. Just do the minimum we have to. So we've got D all the way down to A, so we're all good. Oh, actually, what I've screwed up here is that this just keeps incrementing, doesn't it? There we go. That's why I have to do it like this. There we go. That'll be better. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. Now that's what we want. Now I should be able to store and read those. Okay, what's the problem there? Oh, my functions didn't line up. And this will fail because I need to convert them back into an int at this point. See you in with the int, wherever I screwed up there. There we go. No more int. That's better. Cool. Now test. Here we go. I think I need to clean that because that doesn't look right. Yep, cool, okay. Yeah, okay, there's a bit of state that I'm gonna have to include in there as well. Okay. So that's the Y position, so I need to dereference. I don't know where that Y object comes from. Okay, just comes from linear. Cool. And D3 is the X position. D5 is what? Solidity type bit. Well, let's just set that to 0. Don't know what that will be. And set D6 to 0 as well. So that says 0 for no flip. And we'll set pointer to angle buffer to, actually, is there an angle? No, we'll set it to 0 for now. Just leave it like that then. It's all good. Okay, so it's actually executing it. Okay, but we haven't actually called find flaw, have we? So if we go to our test, Okay, it's failing. Okay. It's failing. It's probably segfaulting, I guess. I don't know. Yeah, it's probably segfaulting. If it's not, I don't know, if it's not saying much, it just might be segfaulting. What can I do to kind of test that out? Probably just leave this out. What can I do? Yeah, seg fault. Okay, well, I don't want to debug a seg fault right now, so I'm gonna have to leave it there. Anybody gonna got any questions about what we've been doing today? I'm pretty happy with the test that we wrote. I'm really happy with that. Hopefully we can get a test going for this find flaw function. That'll be super good. I don't know what the seg fault's about. It's probably trying to access some memory on the ROM that it shouldn't be accessing, and it's probably because I've set like, you know, I've set like this thing here to 0, and then when you try and emulate it, it's probably seg faulting the emulator, and so crashing. So that'll be something I want to debug later. It's not something I want to debug right now, especially since I've got a heap of work to do, and it's 12 o'clock, so I probably should get started. Awesome, thanks for coming by. Yeah, okay, so let's find a stream to host, and what's different now is that we have tags rather than categories, so I don't have my functional programming category that I used to like, so now I've got to go through tags. Movie showcase website. What's this? Programming something. That's me. Pokemon. That's doesn't seem like programming, but okay. Here we go. This one's closure. That'll do. So what's this one? Is that an L or an N there? Alright, well, thanks for everyone coming in today. Next week, I'll actually probably not do Sonic. Next week, we'll try and I'll do more FP course. We'll do state and state T. So we'll do some more FP course, do state and state T, which are really good modules. I highly recommend them. And we'll get going on that because we haven't done those ones before. After that, we can go over to doing the parser modules on FP course. Those are really good as well. So next week we'll do state and state T. Week after we'll do parser, more parser, and JSON parser, because those are really, really good. Cool, so say hi to this person. They're programming a TradeBot enclosure. I'll upload a video of today, and I'll see you all next week. Thanks for coming by.